This is the second video for motion under a variable force and acceleration. Now, if the velocity is given as a function of position x and the acceleration is required as a function of x, what we know is that our acceleration is equal to dv dt. So that can also be written as, using the chain rule, dv dx times dx dt, knowing that our dx's would be cancelling and we'd be left with our dv dt. Okay, but when you think about that, we know that dx dt is equal to velocity. So that means our acceleration can be written as our velocity times dv dx. Okay, and that's the formula that we will use for a lot of the examples from now on. And it also means that we won't have to learn other formulas. If you know this one, you can derive other things. So this is a very important one to remember. So the example for this video, the velocity of a particle moving in a straight line is given by v of x equals 2 plus log e of x for x is greater than 0, where x is the position at any time t. Determine the acceleration in terms of x. So v is equal to 2 plus the natural log of x, and that x is greater than 0. So that means our dv dx, if we differentiate, is going to be 1 over x. Our acceleration, as we've just shown, is equal to v times dv dx. And I suppose if you didn't want to remember the formula, you could derive it every time. Plugging in v, so that's going to be 2 plus log e of x times by dv dx, which is 1 over x, which we just found. So our acceleration is equal to 2 plus log e of x all over x. Or you could write it as a equals 2 plus ln of x all over x. For this example, you can complete questions from MathQuest Exercise 12C, page 571, questions 4 to 7.